So let's move on a little bit. And one thing I wanted to cover was I'm sure everybody has seen this video because the Globers have wasted no time making sure it was everywhere by a YouTuber by the name of Soundly, okay? And I don't know if you guys have seen it yet, John or Jaron, but I know Karen has. And basically what Soundly is saying is that they have found curved water, and they make this, he draws this conclusion by this picture that we're seeing on the screen here. Now, to say that there's a lot of things wrong with this would be an understatement, and we're going to actually go through those here in a minute. But I did want to point out that Karen and Dr. Zach did a debunking video on this, and your material was great, you guys. It really was. Awesome. And unfortunately, the rebuttal was, well, you guys got the wrong set of towers. You got the wrong set of towers. You're so dishonest. Everything's all wrong about this. So the first thing I have to say about that is like, okay, great. They got the wrong set of towers, but really, it's a lake. What difference does it make? Do you really think that one set of towers is going to show curvature, whereas another set of towers doesn't, or whatever? Especially if they're more or less in a straight line. And of course, the ballers, Karen, are claiming that the towers that Soundly is using here are in a perfectly straight line, and that may or may not be true. I believe that you said that you found some other evidence where they're slightly off, but there's much more wrong with this than whether or not the towers are lined up. And of course, one thing I could not ignore was the first person that got behind this was none other than Charles Flat Earth Math. Now, I just saw him make a comment to somebody in the chat a little while ago about, point out one time I've ever lied. Well, I'm about to do that, Charles. Charles has gone around, and you can find his comments on several videos, because this is what he does all day long, by the way. And he says, in every other video up to this point, he has said, do you even understand how big the Earth is? There's no way you can see this curvature from the ground. And he usually does this on videos that are about not being able to see any curvature, right? And so if you look, all you have to do is just look a little bit, or if you've been in the community, you're fully aware of this. He's saying, that's ridiculous. The Earth's way too big to be able to see any curvature anywhere at all. So the first thing Charles does is he jumps on this, and he even used it in his debate with Antonio, talking about how flawless this is, and this is that one rare circumstance where the curvature can be seen. Well, that's one reason why we're going to take this apart, because, first of all, there's several things wrong, but Karen, do you have any comments you want to make on this before I start tearing it up?
Well, I mean, we did point out the wrong towers, and that was just an honest mistake, but the point of the video still stands. I mean, you're not going to see the curvature in this one magical spot on Lake Pontchartrain, and and you can see in the pictures, there's clearly lots of distortion going on there. There's miraging, there's refraction.
Yes, I mean, there is a whole lot of it. Not to mention the least of which is he shot this with a Canon Rebel, which ultimately optically is a piece of junk. And we're going to prove that, by the way, because these are a lot of the things that I caught on, first of all. And so one thing I want to get out of the way really quick, Jaron, with you and Morgile, is Cammie said something to me that you may have said, may or may not have said, and I'm not sure if you agreed with this, but you may remember several shows ago we were talking about how I brought up the point where you can see a lot more distance going across the horizon left to right than you can going front to back or out forward, right? Because somewhere to the horizons it's like 3 to 6 miles, and easily, like when we're in Hawaii, for example, there are points on the beach on Maui that I can stand there and I can see the entire island of Lanai, go across, see the entire island of Molokai, and so we're talking over 60, 70 miles easily across those. And I would say that a fair bet would be able to see horizontally across a distance of 100 miles. But she said that you were, at least she was under the impression that you didn't think that was so because, you know, of the way that we view things in a circular pattern. So I just wanted to get that clear with you.
Well, and I tell you, you can ask Missy, you can ask David Weiss, anybody. I've been saying that for 2 years, and I keep getting told I'm absolutely incorrect. I've been saying we can see further left and right than we can forward, and everyone says you're an idiot. We see in a circle. So I'm totally with you. I kind of went to that circle belief because I can't really see how it would work that we would see further left and right, but clearly we can. And the only thing that might be true is that we're actually seeing 60 miles straight out as well. I mean, I don't know, maybe things going straight out have, you know, reduced in their size so much.
No, it has to do with your line of sight and the angles relative to your line of sight. And so whatever's directly in front of you is going to be more or less aligned to your line of sight. And so things are going to compress, and the operation of perspective is going to act most heavily on those areas that are directly in front of you. Now, the further and further askewed objects, say train tracks or islands, get from your line of sight, the more distant their convergence point is. And so, yeah, you can definitely see.
Let me give you an example, and you tell me what. So if we're standing at a beach, and there's a island on our left that is, okay, let's say that's island A, and then on our right, far away, there's island B, and the distance between those two islands is 70 miles. Now,
right.
How far in front of you can you see?
Well, okay, so your optical horizon is, say, 3.5 miles. But those islands are obviously going to be, say, 50 miles away, right? And so that's how, because your line of sight converges with the horizon directly in front of you. But if something is even, you know, directly in front of you but much taller, like a building, especially when you get off to the sides, you have a wider field of view. Gosh, it's hard to explain, but imagine if you're standing on a set of railroad tracks. Those railroad tracks are going to converge to a point. Now imagine that there's a set of one rail 30 feet to the left of you and another rail 30 feet to the right of you running parallel to those tracks. Those rails to the left and right of you are going to appear to converge much further along that datum line than the tracks that you're standing on. And so it really just has to do with how our eyes work. And of course, that optical horizon on the ground cuts off your line of sight at about 3.5 miles. But anything that's 50 miles away and say 1,000 feet tall or whatever, you can see it like an island. You could probably see easily 100 miles across. It's just according to how clear of a day it is and how tall the objects are, because eventually even the tallest mountain will merge with the horizon due to perspective and atmospheric lensing. I don't know if I'm confusing it, but yeah, I agree with you. I think that makes perfect sense that you can only see to your horizon